Hello, welcome. In this short video, let us look at the plotting of a hyperbolic function. Specifically, we are going to plot both sin h function and cos h function. So, plotting of hyperbolic functions or signals when the variable is basically time. So, for example, we want to plot cos h of omega naught t, which is defined as e power omega naught t plus e power minus omega naught t divided by 2. So we can observe that the cos h function is basically an average of the real exponentials, that is e power omega naught t plus e power minus omega naught t. Similarly, we can also define sin h function, sin h of omega naught t, as e power omega naught t minus e power minus omega naught t. So the average is the cos h function, and then the half of the difference is the sin h function. Now let us plot these functions or signals with respect to time or using Matlab. So here is the Matlab code. So we create the time vector, and then in this case let us assume it is equal to 2 pi by 75, or we can choose any other value, and then x of t, and then we define two signals, x of t, that is exponential of omega t, and xt1 as exponential of minus omega t, and then we can define our cos h function as the average of these two functions or average of these two signals, and we can define the sin h function or sin ht as the half of the difference between these two signals. Now once we have generated the signals cos ht and sin ht, we can just plot them. So plot of t comma cos ht, and with different plot characteristics, and then similarly we can also plot t and sin ht. Let us look at the results. So for the given frequency, we can clearly see the shape of the both signals. That is, for example, for cos h function, it has a convex shape between -5 and +5, and the value changing from 1.1 and then goes slowly to close to 1, and then it will come start to increase again. And then sin h function looks like a linear curve for the values from -5 to +5. But if you change the omega naught, you can clearly observe that the sharp change in the values of the signal. That is, for example, if you increase the frequency to 2 pi by 15, you can see that both the signals are now looking non-linear, because in the sin h also looks clearly non-linear. So the value also changes, that means the amplitude increases. So in this case, the maximum value goes above 4, and as omega becomes larger and larger, the cos value and the values of the cos h and sin h also become exponentially larger. So to summarize, in this video we have looked at the plotting of hyperbolic signals such as cos h signal and the sin h signal. So the cos h is defined as exponential of omega t or omega naught t plus exponential of minus omega naught t by 2, and sin h is defined as the difference between exponential of t and exponential of minus t, or exponential of omega naught t and exponential of minus omega naught t, and divided by 2. So then we can generate the time vector, generate the two components of the signal, that is x of t and x of minus t, and then we add them and divide by 2 to get cos h function, and then we find the difference and divide by 2, we get the sin h function, and then we plot the two signals. And then the shape of the signal and the magnitudes or amplitudes depend on the frequency omega naught. So we have clearly observed that when we increase the frequency omega to say 2 pi by 15, the values of the signals, that is the amplitudes of the signal, both cos h and sin h, increase dramatically. Thus we can plot the hyperbolic signals using Matlab. Thanks for watching.